The use of artificial intelligence in various scientific disciplines is growing rapidly. There are many recent studies that utilize AI to improve the quality and efficiency of weather forecasting. However, the question remains as to how useful these new tools actually are and whether they will soon replace meteorologists altogether. In this talk, we will discuss the current use of AI in meteorology with a focus on numerical prediction of the weather. First off, what is numerical weather prediction? Numerical weather prediction, or NWP for short, is the application of mathematical equations to forecast the weather and other aspects of the atmosphere. Weather prediction can be done qualitatively by studying weather maps and using experience and knowledge to make forecasts. This is called a qualitative forecast. However, when the weather is more complicated, such as during the approach of a tropical cyclone, it is often difficult to make an accurate forecast using only experience. And then numerical weather prediction comes into play. In order to make numerical forecasts, we must first collect a lot of data about the current state of the atmosphere. These data are assimilated into a mathematical model which uses the equations of motion and other relevant physical laws to calculate the future states of the atmosphere. In practice, this means running computer programs that contain a set of mathematical equations that describe how the atmosphere behaves. The program uses information about the current state of the atmosphere to calculate how it will change over time. These calculations are made for a large number of vertical and horizontal grid points in the atmosphere. Each grid point represents a certain volume of air, and the mathematical model calculates variables such as temperature, pressure, humidity, and wind speed at each grid point. This process is usually referred to as a weather forecast model. Some examples of weather forecast models are the European Center for Medium-Range Weather Forecasts, ECMWF, and the American GFS, Global Forecast System. These models run on supercomputers and produce forecasts for the coming days. They also produce a lot of output data. This data can be visualized in the form of maps and charts that can help meteorologists to identify weather patterns and trends. While numerical weather prediction has been used for decades, there is still room for improvement. For example, weather forecast models tend to have a resolution of around 10 kilometers. However, some weather phenomena such as thunderstorms occur at much smaller scales. Therefore, researchers are constantly working on improving the accuracy and resolution of numerical weather prediction models. One way to do this is by incorporating machine learning into the weather forecast process. Machine learning is a subset of artificial intelligence that involves training algorithms on large amounts of data so that they can make predictions. In the context of numerical weather prediction, this means training an algorithm on historical weather data so that it can learn the relationships between different weather variables and make accurate predictions about future weather conditions. One way to utilize AI in NWP is to improve the accuracy of the forecasts. This can be done by using AI to correct errors in the raw data or to improve the resolution of the forecast model. For example, in a study published in Nature in 2021, researchers from the Max Planck Institute for Meteorology in Hamburg, Germany, used a machine learning algorithm to correct errors in satellite-based precipitation data. The algorithm was trained on a large amount of historical precipitation data and was then used to correct errors in real-time satellite data. The corrected data were then used to improve the accuracy of a numerical weather prediction model. Another study published in the same issue of Nature used an AI-based technique to increase the resolution of a weather forecast model. The researchers used a method called deep learning to train an algorithm on high-resolution weather data. The algorithm was then used to upscale the low-resolution forecast model data to a higher resolution. The results showed that the AI-based technique produced more accurate forecasts of precipitation and temperature than traditional methods. Another way to use AI in NWP is to reduce the computational cost of running weather forecast models. Weather forecast models are computationally expensive to run, which limits the frequency with which they can be updated. However, AI-based techniques such as neural core prediction can significantly reduce the computational cost of running these models. A study published in 2021 by researchers from the University of Reading in the UK demonstrated that their AI-based technique can reduce the computational cost of running a weather forecast model by up to 95%. This could allow for more frequent updates of weather forecasts, leading to more accurate predictions. However, despite all these advances, there are still many challenges associated with the use of AI in meteorology and numerical weather prediction. One of the main challenges is the availability of high-quality training data. Many of the AI-based techniques require large amounts of high-quality training data in order to work effectively. However, weather data can be incomplete, noisy, and subject to other forms of uncertainty, which can make it difficult to train effective AI models. Additionally, there are concerns that AI-based techniques may not be robust enough to handle rare or extreme weather events. Since most AI models are trained on historical data, they may not perform well during extreme weather events that have not been seen before. Finally, there is a risk that AI-based techniques could introduce new errors into the weather forecasting process. If an AI model is trained on incorrect or biased data, it could produce incorrect forecasts. It is therefore important to carefully evaluate the performance of AI-based techniques and to ensure that they are used appropriately in meteorology and NWP. What's next for AI in meteorology? Despite these challenges, there is a lot of potential for the use of AI in meteorology and NWP. As AI technology continues to develop, it is likely that we will see even more innovative applications of AI in this field. One promising area of research is the use of AI to improve the understanding of complex weather phenomena such as hurricanes and tornadoes. By analyzing large amounts of weather data, AI algorithms can identify patterns and relationships that are not apparent to humans, which could lead to a better understanding of these phenomena and improved forecasting capabilities. Another promising area of research is the use of AI to personalize weather forecasts for individual users. By analyzing a user's location, preferences, and other factors, AI algorithms can generate customized weather forecasts that are more relevant and useful to that individual. In conclusion, the use of AI in meteorology and NWP is still in its early stages, but it has the potential to revolutionize the way we forecast and understand the weather. While there are still challenges to overcome, the benefits of using AI in this field are too great to ignore, and it is likely that we will see even more innovative applications of AI in meteorology in the years to come. I hope you enjoyed this brief introduction to the exciting field of AI in meteorology. To learn more about this topic, I recommend checking out the references provided.